when we push to deeper limit, sometimes if we start seeing like 600-700K casing string, that's considered quite deep, and we might actually have to see the casing head and take that kind of load. So that's how we talk about the load, and then we seal off, then the initial pressure containment that I emphasized just now. And each annulus we should able to access as we come to a surface wellhead. Subsea, whatever we say here, I think is in general, but it's always a case by case basis, right? That subsea we couldn't actually access the annulus and things like that, and then we need other mitigation like FPV. You guys heard about FPV? Annulus pressure build up, right? So that means we couldn't. Subsea wells like that, we couldn't actually access, we cannot pump it. We don't have valve like surface here, you can just pump it. For subsea, it's all on the seabed. So we couldn't actually pump anything in, so we have the FTP modifications. And then it is quite driven by the simulations now. I think the simulation now is quite accurate as long as we put the input rightfully, right? So that's how the annulus space, and then it's also to support both BOP and tree. So on top of the casing load, we talk about also about the BOP weight, because every single wells they are all freestanding. There is no load onto the platform. The whole well's architectures will really loop to the first string, which is the conductor. There might be some exception case because there are always different casing design, different method to complete wells. Sometimes you might heard slim bone wellhead at Gulf of Thailand, they use a lot. But in general, it's not. They are all actually freestanding. There is no load on the platform. Okay. So this is the whole installation sequence. This is really a typical conventional wellhead, where we really have a casing head as a starting. Then we have the casing spool, then we have the tubing head. So when we really construct this well from scratch, first thing is we actually have the solar prepared. Imagine this is an onshore well. Let's start with the most easiest one, which is the onshore well supply. So offshore typically is more costly now. So then you start seeing some slightly different things. So this is a typical casing program 20. So they have three spool, three housings here, and then this is a casing program just for example. So if we are using 20-inch conductor, so basically we are prepared a sonar. So what the sonar means is actually onshore wells. They will actually excavate the soil. They will make a sonar. So the sonar, there are various ways. Some they put concrete because they don't want the soil to collapse when you work on the wellhead or even production. So maybe they will dig up. Then you install the wellhead. So that's how they prepare. The video later will show a little bit how it roughly is. It can be a square or rectangular size footprint. So you install a conductor. It can be a piling. Sometimes we do drilling as well. Drilling we will also do cementing. Because when you drill a bigger hole, you run your conductor, you need cement to support the whole way. So then we really install the first casing head. So just at this program, we're really using the first one is a diverter now. So to associate with grid equipment, the diverter and BOP used together with the wellhead to build the whole pressure containment, which they are all the well control part of the well control equipment. So diverter and BOP they are different. So they actually function differently as well. I can brief a little bit different what the difference is. So we put the diverter for shallow gas asset, then we spot the well, drill for surface casing, then we will screw is installed, then whenever we install wellhead, we try to test it as soon as possible. Because why? Any clue? Why we must test it as soon as possible? Yeah, so operation wise, we want the seals is good, it's holding before you move on. But nowadays there are some wellhead design that you can only do tests like after that. Put on the next wellhead, then only you test. But I think nowadays we introduce more facilities. I mean, later I'll show how to do the testing as well. So we try to test it as soon as possible. So we don't need to back do the things. So just for example, if we can land the casing hanger, then we test it. Compared to if we want to land the hangers, we put the next wellhead, then only we test it. If that stage we fail, we basically have to pull the casing hanger. So those are incur a lot of non-productive time. So the objective here now is doing a lot of testing before, as soon as possible. When we install this piece, we want to verify the integrity. So BOP test is one thing now. But if we put BOP on top of the head, then we will do the test now. Right. We test for. But if that time I feel I need to take down this BOP, then there's MPT hours incurred, which we try to avoid. Those days is quite a standard product. After that, we do the BOP test, that's fine. But now people don't want to do. If the seal fail, then we have to redo a lot of things. We incur a lot of MPTs. I will show this on YouTube first. So guys, okay? Any questions? Just do concrete, some they even put a steel plate to barricade. So the worker go in and look at the safe. That's how we drill with diverter for the surface casing section. So we run drill bit, drill the surface casing section. Then we run the casing. So when we do the cement, I think loud attender here already, right? So you guys know the cementing, right? So the casing, the bottom have a float, so it's a lot easier way. So you push out all the cement. So the cement is supposed to go up. So at this stage, all will be outside of the casing. This is a whole convention, 3 screws. design the final cut. This is one of the most critical. The DSB is supposed to witness at least. So make sure the cut is correct as planned. If not, everything will be erased. The tree will be very hard. Then you might problem to actually look up to the front line. And that's always have to confirm with facilities. So just now you see they talk about the testing, testing. So once we land this one on the casing, the test it straight away. After testing pass, then only we proceed to the next operation. Then the next action typically BOP like in this case. So just now we talked about BOP test. We run the test plug, and this test we actually couldn't verify the seal below because test plug is up here. So sometimes we need to really know where the test plug sit and where we supposed to know the integrity. If it's not, then we need to ask the provider and we need to put on additional test port and all this. So that's how it is. We tested just now, so we proceed. But imagine whatever it is, if the next test is below, right? If at that stage we fail, we have to remove this green color piece. We need to remove the BOP, and those are really prolonged activities. So this BOP test, is for connections. So whenever we say BOP test, actually a real full BOP test is actually testing the RAM. So if you know the BOP, you guys have attended something on the BOPs? Okay. So BOPs is where we prevent the blow up. So when we have a gas come up, we can shut in the valves. So there are various RAM. The RAM will actually go over pipe or they will cut pipe. It's basically isolate the whole things, whatever come up from the valves. So the valve is safe. If not, the blower will keep flowing. And if the RAM doesn't close properly, it will leak. So this BOP equipment supposed to test according to FBI 53. So FBI 53 tell you this piece you have to do frequent tests. Every 21 days you must conduct a full test. Each RAM, so when we drill, we know you definitely can close it in any time, in the required timing as well. So that's how it is. By this BOP test, when we set a test plug just now there, it's really just to test this connection. Because when you put the equipment, a BOP on the wellhead here, there is always connection, right? Wellhead connections. And the wellhead connection with whatever gasket, proprietary seals gasket, they are all isolating. So it establishes a whole pressure containment, right? So with that, this one, the test plug is just to do this test now. But what normally now we do is BOP will do the full stack test offline. A full stack test can vary from like 4 or 5 hours to even 8 hours. So that's why we now most of the operations we request rig and all this to have the offline testing capacity. So they basically will put a test down, they put the BOP there, they do the full RAM test. So they might actually do it offline, even let's say during rig cut time, but they are not using our drilling time to do the full test. Imagine this one do offline, 8 hours is nothing. It doesn't incur any rig time. But if we put this BOP on the wells itself already, we need to incur 8 hours. And that 8 hours must be waiting. So sometimes when you go offshore, BOP test you witness a few times, you feel boring also because it's very lengthy. And you need to witness certain things like that. So, and quite normally it tested good, but you were surprised also sometimes the thing is new BOP. Maybe like a certain drill ship rig is a new BOP. All offline tested good, on the wells failed. And we have to actually demote back and spend weeks just to fix the BOP issue. So that's how it is. So we do offline. So on the well itself, we try to reduce the full stack up price. Yes. When we are drilling the wells, that's why we need the 21 days windows. If you really have the long drilling sections, no choice lah. On the wells, you need to do the 8 hours. Is 8 hours lah. But 8 hours is time is go lah. Because rate, our spread rate is typically talking about 250,000 US dollar per day. So that's include everything, the rig rate and all the service personnel. Every personnel there, even they are not doing work on their time, on their operation time, you are paying them for their rate. So that money costs a lot if you talk about 8 hours there. That's how we do the BOP test.
But for human test in the BOP of Guan, you have to do with the API certificate because like we are saying that every time that you wait to BOP because it's not connected to the well.
So you put on the test time, whatever the ramp above is tested good. It's only when you put on this wellhead, this connection.
You need to put this
So this is probably half an hour lah. When we talk about this test, when we put this BOP on the wellhead, half an hour, just connection test. So that's what we means BOP test is actually really the connection test here. Yeah. So just don't confuse lah. I think sometimes we miss out as well. So after this YouTube, this video really is the voice is very popular. So this is a web machine. But then very the voice of itself also not good. Not very good.
After the hole has been drilled for the intermediate string, the casing is run in the hole.
Sorry, back to the web machine. You guys know what the web machine is?
To protect the profile.
The profile, why you want to protect? Sealing areas there. Basically, the wellhead ID, they have an area which the hangers on the back of will seal. So that area need to be protected.
Hole is then removed, and the drilling operation can resume. After
we set the
the
web
drill for the
machine,
intermediate string, the casing is run in the hole and cemented in place. The intermediate string is cemented to a predetermined depth to ensure a good cement bond is obtained between the surface casing and the intermediate casing. A cement plug is left in the intermediate casing, just as it was in the surface casing. The casing is then suspended from the elevators at the rig floor.
So just down here, you guys can recognize this is single wiper plug or dual wiper plug. Single plug, right? You can see that.
A cement plug is left in the intermediate casing, just as it was in the surface casing. The casing is then suspended from the elevators at the rig floor, and the casing hanger is installed either through the BOP system or underneath the BOP system. In this example, the casing hanger will be installed underneath the BOP system. To begin, the BOP system is nippled down and picked up to a height of approximately 3 feet. The casing hanger is then installed.
So casing hangers, we have two types. One is the actually manual type. We'll cover later in details how a casing hanger looks like. But this is the second type, which is a stick hanger. So slip hangers is where after cementing, then we need to set the slip hangers, then we cut the casing.
Holes are cut in the casing to allow the drilling fluids to drain out of the casing riser. When the casing is drained, a rough cut is made and the balance of the casing riser is removed. The BOP system is removed. The casing spool with a crossover seal is installed. The BOP system is nibbled out and preparation.
So this is a little bit less ideal one, what we say, right? The old days, they actually will put the wellhead, then we need to do the testing. Because these slip hangers, they don't have test spot here. So what happens is at this stage, if we put on the wellhead here, if it's filled, then we have to look down, maybe check whether seals damage or not. So imagine the same things if I add a test spot here, I can provide testing. At that stage, I already know this hanger is sealing or not. So when this hanger is sealing, I remove one possible cause. So when you put this wellhead on top, if it's filled, it's only this seal will leak. Because here you already verify. So all this testing time, we are talking about maybe 15, half an hour. But it does help you to actually go back to the first stage. Because if we want to redo everything, MPT hours, probably a couple of hours. We start doing no straight application.
Is made to drill out for the production casing string. To test the BOP system, the test plug is made up of the drill string
You
and
start
loaded
seeing
through the
repeated
BOP system until properly located in the casing spool.
operations.
Pressure is applied from above the plug and the BOP system is tested. Upon completion of the BOP tests, the wear bushing running tool is made up on the drill string
As
and the
plug,
wear bushing
then you
installed
set
on
the
the running tool.
pushing, rotate, then
The
you
wear
drill,
bushing is then
one
loaded through
casing,
the BOP
then you
system
cement.
until located in the casing spool bowl. The wear bushing is locked in place either by lockdown pins in the casing spool flange or by lockdown pins located in a lockdown flange.
And this
The
one,
running
you
tool
can
is
see
then
that
removed
don't
and
pass
the
through
drilling
the-
operation can resume.
Yes.
The production casing string is generally run to the total depth of the well and is the casing string in which the production packer is installed. When the hole is drilled and the production casing is run and cemented in place, the casing hanger is installed. The casing riser is drained, a rough cut is made, and the BOP system removed. The final cut is made to the production casing in preparation for installation of the tubing spool. The tubing spool with a crossover seal is installed in the same manner as the casing spool. After the tubing spool has been installed, the seals and connection are tested, and the BOP system is nibbled up. Preparations are now made to run production tubing in the hole. Production tubing is considered any pipe string 4 inches in diameter or less, though sometimes larger sizes of pipe are used. When the plug has been drilled out and a cleanup trip completed, the perforator is up the packer.
And you repeat the similarity.
After the tubing is spaced out and proper weight set on the packer, the tubing hanger is installed at the tubing on the rig floor, then lowered into the bed with the tubing spool.
With tubing hanger.
The BOP system is nibbled down and preparations are made to install the production Christmas tree. Will shut down the well
So
in an
after
emergency and prevent damage of the equipment downstream. To install the Christmas tree, determine the direction the Christmas tree should be installed, pick it up, level it, and lower it over the extended neck of the mandrel tubing hanger. The Christmas tree is nibbled up to the tubing spool, and the connections and seals are tested. The well is now ready for production testing.
So after the capability on the casing hanger and casing screw, and then you start the casing screw.
Sorry again.
After you for the sequence in the start.
Okay, there is slightly
After that, after you put the duplicate, and then you install the Christmas tree. So the BOP install, really continuous for example.
Foundation is not. This foundation is inclusive of tubing hanger.
Oh, okay.
Because tubing hanger is part of upper completion.
Mm.
So it is part of the completion suite. So that's what I mean. Tubing hanger is part of the foundation, so we can't install. And after this tubing hanger landed, then the battery.
So, in the video, after you put the duplicate and the completion install, the BOP is installed and ready for use. That's it.
There may be several strings of pipe in any given well. The number of the strings is determined by the number of zones being drilled. At the packer, after the install of production Christmas tree,
After tubing hanger,
the seal flange, which is often called a tubing head at the
after
packer.
the BOP.
After the tubing is spaced out and proper weight set on the packer, the tubing hanger is installed at the tubing on the rig
Because
floor.
tubing hanger
Then loaded into
is
the
actually
tubing
count
spool.
like major hanger. So we are not
The
counting
VRP system is nipple down and preparations are made to install the production
Why
Christmas
we
tree.
don't do that is because tubing hanger don't have sleeve hangers. Tubing hanger, they are all major.
The production
Somehow,
Christmas tree
you
is made up of a
see
seal
that
flange,
later I
which is often
will
called a tubing
remind
head
or
adapter,
point out the
a
difference
series of
between
gate
major and
valves,
sleeve.
a T
And
or
why
cross,
people don't use the
ring
tubing
valves or side
hanger
valves, and a
with
choke.
sleeve tightener.
The Christmas tree is the group of equipment
We
that
are not
controls the flow of the well.
Okay. That's good.
So, is it correct to say orange is slip, purple is tubing hanger?
So which one you talking about?
Orange is
Orange
slip.
is a seal.
Seal.
This is a back.
And then purple on the top is tubing hanger.
Purple on the top is tubing hanger, right? So this is seals in our seals. So this is really like bottom we set and start to your head. But the design is slightly different. Just now is the real basic and base view. I think when we introduce more on the wellhead components, then we can have a better view. But the installation sequence there is just really to get you the rhythm. When we run, when we install wellhead, then when we drill, then we run a casing, then we cement, and then house the hangers and all this install in place. Just out there is no major hanger except like the tubing hanger you see. Tubing hanger is really like major hanger type. Okay. So we talk about the interface, the rig interface. So just now we talk about diameter and BOP. So so what are the diameter and BOP? They are actually different pieces of equipment which require on different stage. So by right, diameter is only to divert the flow. We cannot shut in the wells with diameter. So what happens is when we